Over next few minutes, we would discuss about the following topics. What is cloud computing? How it works? Deployment models of cloud computing. Cloud security. What is cloud computing? The storing of data and applications on remote servers and accessing them over the internet rather than saving or installing them on your personal or office computer. Now consider you have a dog and his name is Jack. You and Jack are best pals. You go on walks together, Jack walks faster, but still you love him a lot. You have only one photo of Jack though, because you love this really named dog so much that you worry you might lose his photo. So you upload the photo, your only and favorite photo, to one of your favorite photo websites like Flickr, Facebook or Instagram, and without realizing it, you just started cloud computing. But what does that mean? When you put Jack's photo online, you can picture a giant cloud coming down to vacuum up his photo of your laptop. Then this photo of Jack lives up in the cloud and tells you to have a look at it again. You log on to Flickr, Facebook, and there's Jack. You can see him from wherever you want, from home, from work, even on your phone in case you start missing Jack during your lunch break. At first it seemed like magic, but it's actually not. Jack's photo actually lives in a secret warehouse full of computers. These warehouses are called data centers or server files, and they're popping up all over the world just like crops. Inside one of the computer warehouses, there are rows and rows of refrigerator-sized computer towers. They're way more powerful than your home computer. It's hard to make out where your favorite photo of Jack is. Maybe once it's in the cloud. That's because that may be in a dozen of these warehouses all at once. Jack may be chilling at Paris or hanging out in India. There's no way to know for sure. You just have to trust a web company like Google or Microsoft to keep Jack safe. There are a bunch of reasons to do this. First is that, well, you only have one photo of Jack and it's on your laptop. And if that laptop breaks or if an alien comes to steal the laptop, then no more laptop, no more data, no more Jack, and no more memories. So when Jack is on cloud, he is stored not in one place, but all over the place, so you're less likely to lose it. You also can access Jack's photo from anywhere. You can send a link to some of your friends so they can see Jack too. That's just one of the many parts of cloud computing. There are plenty of reasons to be scared for cloud too, but for now you trust and decide to trust the cloud is backup. If Jack's happy, then you're happy.
Now we will introduce deployment models in cloud computing: private cloud, public cloud, and hybrid cloud.
Private cloud. It functions solely for one organization on a private network and it is highly secure. Public cloud. It is owned by cloud service provider and offers highest level of efficiency in shared resources. Hybrid cloud. It is basically a combination of private and public deployment models. Specific resources are run or used in public cloud and others are run or used in premises of private cloud. This consists of increase in efficiency. Cloud computing consists of following service models: Infrastructure as a Service, ES, Platform as a Service, PaaS, Software as a Service, SaaS. By using the ES model, organizations get infrastructure components such as computing power and storage capacity. Here, the organization has control over the entire IT infrastructure, including the hosting environments and applications. However, the organization needs to employ additional staff to maintain and manage the infrastructure and the applications. Microsoft has proposed remote desktops and virtual machines to Microsoft Windows Azure as an ES offering. The PaaS model provides organizations with a platform or a runtime environment to create and deploy applications. Here, the organization is only responsible for the development, maintenance, and management of the applications. Microsoft provides the Windows Azure platform as a PaaS offering. The SaaS model provides organizations with ready-to-use applications. They use a combination of cloud-based computer and storage services. Microsoft provides various online services such as Microsoft Business Productivity Online Suite, DeepHorse, and Microsoft Dynamics CRM Online as a SaaS offering. Now let's discuss cloud security. Cloud computing has been widely adopted across many industry sectors. With adoption come security concerns, but there are ways that ensure privacy and prevention of data loss. We will tell you how to overcome data security challenges in a cloud.
Cloud technology provides loads of benefits, but there are few challenges as well. Data residency and data security, which are the key concerns when moving to a cloud.
The main concern with data residency is that who manages and has access to the data? Where is the data stored? What laws are applied? Will you know when data is breached? Will data remain in the cloud even after termination of service? Data encryption and tokenization are key solutions to overcome data residency concerns. Data encryption is the mathematical process of converting clear text data into ciphertext which cannot be read by anyone other than the customer who retains the encryption key. In tokenization, actual data resides locally in a token database. Randomly generated tokens are associated with the data and are sent to the cloud where data can only be read by the custodian of the token database.
Now, data encryption is the mathematical process of converting clear text data into ciphertext, which cannot be read by anyone other than the customer who retains the encryption key. Encryption requires lighter weight stable servers with no local data storage. While in tokenization, actual data resides locally in a token database. Randomly generated tokens are associated with the data and are sent to the cloud where data can only be read by the custodian of the token database. There are several pros and cons in cloud computing. Some of them are: So cloud computing security boils down to a simple rule: to keep yourself informed. It's a personal decision on what you feel comfortable risking and how much access you want throughout all of your devices. A user needs to understand that even though the service is not perfect, nothing in technology is. And if the need is high for flexibility, then a user has to stay on top of the risks involved. It's a decision that needs to be made after a great deal of research, but find one you are fine with and make sure you monitor how they are maintaining a secure service.
Created using Powtoon.